Hello, we are working on Chapter P and Section 1 of that chapter. Today we're going to focus on graphs and models. So here's our day 1 objective, sketching the graph of an equation. And let's just hop into it. One thing that can help you when graphing functions to get the most accurate graph is to have some sort of idea of the family of graph you're talking about. So if I ended up with an equation like y equals 3x plus 5, I'm kind of zoning in on that x and saying, well, that's an x to the first power. You know, I know x, they turn out to be a linear function. So I have some sort of idea of what the shape of my graph should be like. If I ended up with y equals 3x squared plus 5, now I'm focusing in on the fact that it's an x squared, and I know x squareds are quadratic equations, so it's some sort of parabola. So just having some inkling of what the shape should be like will help us when we're graphing. Another excellent method is just plotting points, and we want to plot enough points so that we can get that shape out. And if I know kind of what to expect, I can make sense of the points, and maybe I need more points to get that shape to come out. Also, another great tool is to use the graphing calculator. When we're doing that, though, we have to be careful that we get the appropriate window so we're seeing the entirety of the graph. So here's an example. Sketch the graph of the equation by plotting points. And our equation we see is y equals the square root of x minus 4. Excuse me. So what I'm kind of focusing on in my mind here is this square root. I've got the square root going on, and that means that the shape, if I just bounce that out of the screen, what's the shape of a square root? Oh, it's kind of like this sort of shape. Starts and then builds, right? So I got that in my mind. I'm going to make an XY table, and I'm going to start plugging in points. Well, if I tried a negative value, I cannot take the square root of a negative value when I'm in the real number system, so I'm going to avoid negatives. I'm going to start with 0. So when I plug in 0, I get the square root of 0 minus 4 would give me negative 4. 1 seems to be a nice value because the square root of 1 minus 4 will be 1 minus 4 would give me negative 3. 2, well, square root of 2 is not the prettiest number, is it? It's not one I can just come up with in my head. Square root of 3, kind of the same thing. But if I go to 4, a nice perfect square, the square root of 4 minus 4 would be 2 minus 4 gives me negative 2. Maybe let's go one more. Let's throw in 9. Square root of 9, another perfect square. That's why I jumped to it. Square root of 9 minus 4 would give me 3 minus 4, or negative 1. So I have, you know, a few points to plot. I've got 0, negative 4, 1, 2, 3, 4. I have 1, negative 3. I have 4, negative 2. And I have 9, negative 1 right there. And there's my square root function. Use those family of graphs to help identify the shape of the function. Number 15 says, describe the viewing window that yields the given graph. And we've got y equals x cubed minus 3x squared plus 4. And it wants to know, what are the intercept values? What are the x values? What are the y values? So basically what I'm trying to figure out is, what is this value out here? What is this? What is this? So that I can get the viewing window, okay? To do that, I've got to use a few clues along the way. Mainly, I think I'm going to go after some of these key points, maybe here and here. Those are called zeros, aren't they? The zeros of the function. They also would be the x-intercept. And to do that, I'm going to grab my graphing calculator. Pause if you need to, but get your graphing calculator. I've keyed in my equation by going y equals and then throwing it in there. Now I'm going to go into my graphing screen. So I'm going to graph it, And I'm going to do a zoom 6 because that's probably maybe where your calculator is at on that standard screen. Are we graphing? There we go. And I'm going to find out some of those key points. So I'm going to go second and trace to get to calculate. And I want to calculate the 0. So I'm going with option 2. And notice how it says use the left bound, right? So I need to be on the left side of my 0. I'm going after this 0 right there where it's intersecting the x-axis. Hit enter. I get a vertical line on my graphing calculator. You may not if you have a different model. So somewhere in this region is the 0. I could guess, I could bring my cursor back a bit, but if I hit enter, I get the 0 is at 2. So this spot right here is 2, 0. Let's go find the other one. Actually, I wouldn't really have to, but we'll go ahead and do it. So I'm going to go back again into the second trace, which gives me calculate, option 2 for 0. I need to get on the left side. Okay, I'm going to hit enter. And the right side, hit enter. Guessing I can bring it somewhat close, enter. And that says the 0 is at -1, 0. Okay, this is plenty of clues to figure out. I'm going over 1, 2 spots and landing at 2. So 2 divided by 2 steps says that each step is value of 1. So that means this would be 1, 2, 3, 4, 5. -1, -2, -3. My x values run from -3 to 5 with a scale of 1. I am counting by ones. Okay, that got me the x scale. Now we got to find the y scale, which could be different. I want this point right here. How can I get that? Well, that point exists when x equals 0. So this will have the ordered pair 0 something, which means that I can take my equation y equals x cubed minus 3x squared plus 4 and plug in 0. So y of 0 equals 0 minus 0 plus 4 says 4. That point turned out to be 0, 4. I can count the number of steps. It took 1, 2, 3, 4 intervals to get up there. 4 divided by 4 intervals says that each interval has a scale of 1. So that must be a top point of 5, and then I'd have -1, -2, -3. This has the same window, -3 to 5 with a scale of 1. So you got to play around with them a little bit. You kind of just have to be a detective to work your way backwards. Today we're going to do assignment on page 8, and it should be in your packet. And good luck with it.